large margin of safety built into protein. We really need about 2.5% of our calories to come from protein. And to be extra safe, they say we need about 5% of our calories to come from protein. Then the RDA comes in, again, is extra safe, and says let's get 10% of our calories from protein to be extra safe. Fruit contains about 5% of its calories from protein, on average. The cantaloupe that I ate was 9% of its calories from protein, but it averages out to about 5. Whole grains have 10 to 15% of their calories from protein. Beans have 20 to 25% of their calories from protein. Nuts and seeds have 10 to 15% of their calories from protein. And vegetables have 15 or 20% on average of their calories from protein. So you can see if you're eating a variety of whole natural plant foods, you end up at about 10 or 15% of your calories from protein. All of those sample diets we saw ended up somewhere in that 10 to 15% of your calories from protein range, which is way more than enough. You don't see veggie people going around with protein deficiency. Now, part of the large margin of error for safety is when we cook food, we saw dietary AGEs. And we said one of those dietary AGEs was called carboxymethylysine.
Right.
Another one's called carboxyethylysine. So what happens is lysine, of all of the 8 essential amino acids, lysine has the greatest tendency, based on its biochemical configuration, to form these Maillard reaction products, they call them, and combine with other things to make new things, such as the carboxymethylysine. Now, once lysine has gone to form a new product, it's no longer available to be absorbed as an amino acid because it's bound up in this new thing that's a cooked food toxin. So not only is it taking lysine away, it's also bad for you. And they've studied this, and within the scientific literature, they call it blocked lysine. In other words, lysine that's no longer biologically available. And there's other ways in which cooking and heating and processing diminishes the availability of amino acids, lysine as well as other ones. And when they give you the recommended reference ranges of how much protein you need, they take that into account.
Okay.
So they bump it up even extra. So the thing is, as we saw in a raw food diet, even with all that extra margin of safety, we're still doubling or quadrupling each of the essential amino acids. And then I'll say one other fast thing. Then there's the whole thing about complete protein, right?
Well, that was, yeah, right.
All right, now that goes...
That's usually the question, because I usually say, well, I mean, everything has amino acids, and you don't have to eat it all at one sitting necessarily, but then
here's
I
the
get
deal.
confused
Well,
about
first of all, when we looked at the human reference range for what humans need for all those amino acids, and we saw all the different diets, again, they were all doubled or quadrupled. In other words, for every single one of the essential amino acids, the needs were met. That's a complete protein. It has all of the amino acids. Now, going back to a little bit of protein history, back to 1911, actually right next door here in New Haven, 2 researchers named Osborne and Mendel got together at Yale, New Haven, and studied the protein requirements of laboratory rats. And what they found was that rats need basically more protein than humans do. Well, first of all, they didn't know that yet. They just knew what rats needed, and they said, hey, the technology had advanced to the point where they could study what the protein needs of rats were, and they found that when rats ate cow's milk protein, casein, they grew normally, everything was good. When they ate protein only from wheat, wheat didn't have enough lysine for the rat to grow.
Right.
And the rats could maintain their weight, but they didn't grow. When the rats, young rats that were growing, consumed only corn protein, they found that not only did it not have enough lysine like the wheat protein, it also didn't have enough tryptophan. And with that, the rats actually lost weight, and they died eventually if they stayed only on the corn protein. So they called cow's milk protein complete, wheat partially incomplete, and corn incomplete. And it wasn't then until the 1940s and 50s that they studied the human beings' amino acid requirements and found that rats' needs and human beings' needs were substantially different. So when you really look at the human beings' needs, corn is a complete protein, wheat is a complete protein, and in our Science of Raw Food Nutrition Level 1 class, I do the whole, over an hour on protein, and we look at all the charts, and I do a really interesting thing. I took my sample diet where I got about 2,000 calories and compared that to my protein needs, and you saw a little bit of that. Then I took 2,000 calories worth of human milk and put it up there, and based on the rat studies, human milk would be inadequate in some of the amino acids. And clearly, it's human beings, anyone needs the most milk, most protein, when they're growing, more than an adult needs. So again, if that doesn't prove it, I don't know what does, that the rat studies are just not the valid reference point. But when you use human needs as the reference point, it's an absolute no-brainer. Dr. John McDougall, who I've mentioned, has a challenge out to any dietitian. He says, you find me a diet based on whole natural plant foods that's adequate in calories, that doesn't supply enough protein. And no one's taken him up on it yet because you can't do it.